All right, now we're rolling, everybody. Welcome to 5.3 circular trigonometric functions. Yeah, cool. Thank you. Of course, circular means circle, round and round and round and round and round we go. Not unlike angular velocity. No one moans. That's good. Okay, so let's go ahead and just jump right in. We've had a reference angle, right? Reference angle. We know what that is. So let's just come up here and draw a reference angle. So let's say I have some angle theta, and I rotate over here from my initial ray, which remember we don't even need to draw, and I have this terminal ray. Remember the reference angle would be this right here, theta ref. And we've spent a lot of time trying to find that reference angle. Remember, it is a positive acute angle that lives between the terminal ray and the closest x-axis. There was a question on the test that we just took, and it asked for the reference angle, and some of the answer choices were bigger than 90. If you were taking that test, you could immediately get rid of any answer choice that was bigger than 90 or negative, right? It has to be a positive acute angle. So what we're going to define now is a reference triangle. It's like a reference angle with a tri in front, right? Good. So a reference triangle, yeah, try, which means what? Attempt, right? 3, okay, good, yeah. A reference triangle is formed by, quote-unquote, dropping. Dropping a perpendicular, which I always just say drop a perp, you know? If you ever, like, watch some of those crime shows and there's a bad guy and they're like, freeze, you know, and he doesn't, he runs, then they chase after him. And when they catch him, they tackle him, they drop a perpetrator, they drop a perp, okay? So we're going to be dropping perps, right? Kind of like mathematical law enforcement, dropping perps, which is technically called an altitude. When you drop a perpendicular, which, believe it or not, you could drop a perp up, right? If you've ever seen the tackle tax video, you could see how someone could get tackled and go up first. Ouch. Okay, they're called altitudes. You're going to drop it from some point on the terminal ray, to the x-axis. That is, again, the x-axis, okay? The reference angle that we've been finding all along will end up being the positive acute angle of the reference triangle. It's going to be the central angle. So let me show you what I mean. Come back over here, and you're going to pick a random point on the terminal ray. It could be anywhere on the terminal ray. I usually just pick something that is, you know, on my iPad. If I go too far off this way, I'm off the iPad, right? And you don't want to draw it so close to the origin, you know, so that it doesn't make sense. So just somewhere that's comfortable. All right, so where's the x-axis? Right here. So we drop a perp, okay? And that's called an altitude. And then this makes a right angle if you drop it vertically, right? Okay, and so notice what that creates here is a triangle whose central angle near the origin is the reference angle. And we call that a what now? Reference triangle. Good, we call that the reference triangle. Of course, now that we have triangles, we could talk about side lengths, right? So this right here is going to be an x-coordinate. Okay, it's the distance from the origin to this point down here. And of course, this right here will be the y-coordinate. So that this point on the terminal ray that from which we dropped is going to be a point x comma y. So remember the difference between what the geometry that you studied, whatever it was, last year, 2 years ago, that was called planar geometry, sometimes called plain old geometry. And now we're talking about coordinate geometry. Coordinate geometry. So we're going to put shapes on the coordinate plane. And of course, the father of coordinate geometry is who? No. There's a clue on the poster. The father of coordinate geometry is René Descartes. Yeah. If you look at the yellow poster, it's divided into 4 quadrants. Okay, the coordinate plane. The coordinate plane is also sometimes called the Cartesian plane. Have y'all heard that before? The Cartesian plane. Guess where Cartesian comes from? Descartes. Yeah. They figured it would be too bad to call it Descartesian plane. So it's just called the Cartesian plane. But when you say the, it almost sounds like duh. So it's like, it's the Cartesian plane. Right? Oh, okay. Now, he was brilliant. He was a philosopher. He's the guy that said cogito ergo sum. Cogito ergo sum. I think, therefore I am. Right? Yeah, the ontological argument for the existence of a God. He died very young, like most great mathematicians did. He was always very sickly, and so he spent a lot of time in bed. Lucky guy, right? Well, true, right? But he spent a lot of time in bed, right? And this was way before Netflix, so he wasn't binge watching series. He was binge watching. No, not math. I didn't have math program. He was binge watching Flies. Flies, right? Because like they didn't have air conditioning, so they left the windows open, and so like flies would come in. And so he was supposedly laying in bed one day before he died. This is before he died. And he saw a fly on the wall, right? And of course, wouldn't you like to be a fly on the wall when this happened? And he was watching the fly walk along the wall and then walk along the ceiling. And he was like, you know what? I can come up with the location of that fly. Thank you. Oh, it's upside down. Oh, I got it. Thank you. He said, I can locate the location, that's what locate means, of the fly on the wall by coming up with some distance, it is vertically, and some horizontal distance, it is horizontally. And that can pinpoint the location of the fly. And so that's how the Cartesian plane was supposedly invented. Now, when he invented it, it was really only the first quadrant, but it was expanded to other quadrants. But yeah, so the Cartesian plane, the coordinate plane, came from a fly that was just, here I am, right? And he's like, oh, okay, you're at the 0.35 fly. Thank you, right? Whatever. If flies could talk, they'd be grateful. So anyway, that's just a little mathematical aside. And this is for, Lisa. Can you have Zach who hands to Lisa? The counselor meeting. Yeah, in about 20 minutes. So we got to go fast, guys, okay? So that is called the reference triangle. Reference triangle. Whoa. Okay. Reference triangles are used to find trigonometric values. What the heck's the trigonometric value? We're going to talk about it. Anyone ever stub your toe? Yeah, right? And it starts throbbing. You kind of run some hot water. You put some Epsom salt in a little vat, and what do? You soak your toe, right? Soak your toe. Sohcahtoa! Sohcahtoa. 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 Yes. Yes. Y'all learned about Sohcahtoa in geometry, right? And physics. Good, and physics. Sohcahtoa is a mnemonic device for memorizing 3 of the 6 trigonometric values of a triangle, of a right triangle. Remember that? As your eyes widen. So was sine, and that meant opposite over hypotenuse. Ka was cosine. It was adjacent over hypotenuse. And toa was tangent. It was opposite over adjacent. Those end up being 3 of what turns out to be 6 trigonometric values for a right triangle. Now, I'm going to define what all 6 of them are and why they have those names, okay? So they are particularly important when we're drawing angles in standard positions when they land in any of the quadrants, okay? So let's go ahead and draw the reference triangle in each of these quadrants. We've already done this for the reference angle, but let's just get in the habit now or get used to drawing reference triangles. All right, so draw a little arc that terminates somewhere in quadrant 1 and draw that terminal ray. Remember, it goes on forever and ever and ever. We're going to drop a perp. Ready? Drop a perp. You could drop it from right here. That's good. Or you could drop it from out here. That's good. Or you could drop it from in here. That's good. So it doesn't really matter where you drop a perp. Notice the central angle of that triangle is always going to be theta. And then what would you notice about all those three that I drew here? Those are all related somehow. How they're all right triangles, but they're all related to each other proportionally, right? What do we call those triangles that are proportional to each other? Not coterminal. Starts with S and rhymes with similar. Very good. Those are similar triangles. Similar triangles. Yeah, it's a vocab word. Similar triangles is a vocab word. That means that they are proportional. Okay? So basically, you know, this one could be, let's just come up with some sides like 1, 2, and 3. I'm just hypothetically throwing that out there. If you wanted to make that triangle twice as big, you would just double all the sides. So now that would be 1 times 2 is 2. This would be 2 times 2 is 4. And the hypotenuse would be 3 times 2 is 6, right? We say that those are proportional. They're just a scale factor. And it doesn't even have to be bigger than 1. They could be half as big, right? So that's what proportional means again. They have a scale factor. They share 2 sides and an angle. All right, so in quadrant 1, the reference angle is the same as the angle itself, right? And so the reference triangle is going to have the same reference angle as theta. Okay, good. Let's do quadrant 2. We'll start doing this a little more quickly. Just draw a generic theta and drop a perp from somewhere. Doesn't really matter where. I like to draw it, just kind of try to maximize the space. All right, so this would be our point xy now, and I should have done that over here. Now in this case, x is negative and y is positive. But the length of this triangle is still x, the absolute value of x, I should say. And then the height of this triangle is y, which is already positive, but you can take the absolute value of it. Okay? Now, if we did that, how would we be able to find the length of the hypotenuse of that right triangle? Well, good. Yeah, if we knew the reference angle, let's draw that first. That would be this, of course. If I knew what the reference angle was, then I can actually use what you just said, Sohcahtoa, right? Because if that's the reference angle, this is the side that is opposite. This is the side that's adjacent. And of course, the other adjacent side, that's not that is the hypotenuse. We just call that h for hypotenuse. All right, so if you knew the reference angle, which is why it's important to find the reference angle, you can find, if you know at least one of the other sides, you can find the other one using sine, cosine, or tangent. But let's say we don't know the reference angle. If you know the 2 side lengths, what theorem allows us to relate side lengths to the hypotenuse? The P theorem, right? The P theorem is basically when you gotta go, you gotta go. But the Pythagorean theorem says that x squared plus y squared equals the hypotenuse squared. Now guess what we're going to call the hypotenuse? Not h. We don't call the adjacent a. We call it x. We don't call the opposite o. We call it y. And we're not going to call the hypotenuse h. C would not be bad, right? That's what it is in the theorem. A squared plus b squared equals c squared. Z would be good, x, y, z. How about this? If I come out here to this point, if I were to continue rotating that thing all the way around, it would end up being the what of the circle? No, the hypotenuse would end up being the what of the circle? The radius. The hypotenuse ends up being the radius of the circle. So we're going to call it R for radius. These are, after all, called what type of trig functions we're developing? Circular, okay? So this is the Pythagorean theorem. X squared plus y squared equals r squared, the radius, which ends up being the hypotenuse of our reference triangle. And of course, we know how to find the reference angle here, right? It's 180 minus theta, or pi minus theta. All right, quadrant 3, let's just quickly draw it. Quadrant 3, somewhere over here. There's theta. Drop a perp, and boom, you got yourself a reference triangle. This is the point xy again. And both x and y are negative now, yes? We're in quadrant 3. So the length of this side is still the absolute value of x. The length of that side is still the absolute value of y. So that would be like in planar geometry. If we're just talking about lengths, But in this class, we can have negative x values. We can have negative y values, okay? And, of course, that's still going to be the radius. And the reference angle, which is the angle to which we're referring in a right triangle, is going to be, of course, theta minus theta ref. Now, let me kind of, before I go to quadrant, well, let's do quadrant 4. Sorry, I want to make a connection with the reference angle. Quadrant 4, just for what it's worth now, we can draw an angle that gets us into quadrant 4. There's theta. Drop a perp. I'll do it way out here this time. So this is the point xy on the terminal ray. X is positive, y is negative. The length of this is x. The height of it is the absolute value of y. But we're going to actually label it as y. We can have negative y and x values. Their absolute value is the length. And then this is going to be r. And, of course, the reference angle is this one right here. So opposite that reference angle is still O, and then adjacent to it is still x, and the hypotenuse is still h. So everything that you memorize, Sohcahtoa, it still works, but we're going to have new letters, okay? We're not going to use O, A, and H. We're going to use X, Y, and R because we are on the coordinate plane. Now, here's why it's important if you're on planar geometry. Let's say we have a triangle that's just out here in the coordinate plane. Let's say this was our central angle. From that angle to which you refer, I'm referring to that angle, this is the opposite, and this is the adjacent, and that's the hypotenuse, right? However, what if I was instead referring to this angle? The hypotenuse is still the hypotenuse, but are O and H the same now? No, if that's the angle to which I'm referring, that is now the opposite, and this is the adjacent. So in planar geometry, opposite and adjacent make sense because you can refer to either this top angle or the bottom angle. But in coordinate geometry, we don't need that. Why? Because the angle to which we are always referring is always what we've been calling the reference angle. We will never refer to that, okay? We'll never refer to that as the reference angle. And so there's not going to be any confusion on what is the opposite and what's the adjacent. Y is always going to be the opposite, always. X is always going to be the adjacent, always. And R is always going to be the hypotenuse. Okay? Cool. All right, so let's go ahead and define a trig function. What was Sohcahtoa? It was just some fun thing, right? Now, it's kind of funny. Here's a little story off to the side. We had a physics teacher one year here. She only lasted 1 year. She was from Austin. She was a hippie. Yeah, she was a hippie. I think she moved to Colorado now, where weed is legal. Yeah. Sorry, but anyway, she thought that students would have a hard time in physics remembering Sohcahtoa, right? Sohcahtoa. What is it? Was it Sohcafinger? I forgot it. I don't know. It's just too hard to remember, right? Stubatoa? I can't remember that. So she's like, you know what? I'm going to help you remember Sohcahtoa. And you're like, you really don't need to. I've got it. Sohcahtoa. I've got it. It's real easy. Sohcahtoa. She's like, no. You know, a lot of people forget. No, we really don't. It's Sohcahtoa. It's real easy. No. Let's say you forget, right? Let's say that you are, you have marijuana dementia, whatever. Okay. I don't know if that's even a real thing. Yeah. I don't know, man. Here's what she said. She said to help you remember Sohcahtoa, which no one forgets. She said, okay, here's a little acronym. Some old hippie, SOH, caught another hippie tripping on acid. Some old hippie caught another hippie tripping on acid. And they're like, I think I'm going to stick with Sohcahtoa. She lasted 1 year. Okay? So, overcomplicating things. All right?
That is really easy to remember, though.
Sure, yeah, I know. Yeah, Sohcahtoa, right? Anyway, a trigonometric function, which is what sine, cosine, and tangent were, those are called trigonometric functions, here's what it is. If you forgot or you maybe didn't know, don't ever forget to remember this, by the way. Okay? Super important. A trig function is a ratio of 2 of the 3 sides of a right triangle formed by drawing a reference triangle whose reference angle is theta ref from an independent choice of theta in standard position. Okay? If you want to shorten it down, a trig function is a ratio of 2 of 3 sides of a right triangle. So, in planar geometry again, if this was your reference angle, oops, ref, there we go. This is the opposite, this is the adjacent, this is the hypotenuse. Sohcahtoa. Okay, the so meant that sine, which is abbreviated SIN, it's spelled SINE, of theta. That's how you wrote it. Sine theta, sin theta, but you read it as sine of theta. It equaled the opposite over the hypotenuse. What is the opposite over the hypotenuse? It is a ratio of 2 of those 3 sides of that right triangle. Got it? Okay? Now, instead of always calling that ratio, hey you, or opposite over hypotenuse. I was playing with some ratios yesterday. What's your favorite? Oh, the opposite over hypotenuse ratio. Dude, you should probably give that guy a name. Okay, I was playing with Chuck yesterday, right? Chuck would be a good name for that ratio. The Chuck ratio. What's up, Chuck? But guess what? Someone got to name it. And they didn't name it Chuck. You know what they named it? They named it sine. They called that the sine ratio. That's the name they gave it. So what is sine? It's just a name. It's just a name that's given to that particular ratio. The opposite over the hypotenuse. I like Chuck, but I wasn't at that meeting. Okay? I don't even know if they voted. It could have been like one guy. Sine. All right. Cosine is another name. Tangent is another name, right? Larry, Moe, and Curly would have been great, right? Y'all know who those guys are? The Three Stooges. Yes, y'all are not too young. All right. Oh, did they? Little? With different actors, maybe? I don't know. Definitely different actors, right? Okay. Draw a reference triangle in quadrant 1. Okay, here's what we're going to do. We're going to draw a reference triangle in quadrant 1, just because it's easier. We're going to drop our perp from the point x, y on the terminal ray, and then we're going to label the hypotenuse what? R. And then we're going to list all the possible ratios of x, y, and r. Ready? Okay, so here we go. We are going to come up with all of the trig functions. So here is my independent choice of theta. This is important. You can rotate however far you want and stop, right? Just like the MASH game. Y'all never played MASH? Mansion, apartment, shack, house. You've never played MASH? Yeah, you always start it by spiraling, and the person says, stop. I go, okay. Stop, and then you count 1, 2, 3, 4. That's how many girlfriends you're going to have. No, that's when your zipper's down. Sorry. But you count, and then... Y'all never heard that either? If you see someone with their zipper down, you start counting 1, 2, 3, 4, 5 until they zip it up. And when you stop, you're like, that's how many girlfriends you're going to have, or that's how many boyfriends you're going to have. Y'all never done that? No, we don't stare at people's crotches, but sometimes you see a zipper open and you're like, there's an open zipper. Huh? Yeah, it's your way of politely saying, hey, your zipper's down. That works too. Man. Okay, yeah, so let's try and bring that back, okay? All right. So anyway, the point I'm trying to make is that theta is independent, right? For functions, we have independent variables and dependent variables. No, none at all. The independent variable for a trig function, the independent variable is theta. Rotate and then stop where you want. I'm going to stop right there. That was my independent choice. No one coerced me into doing that. That's my independent choice. That is theta. Now, once you stop, you're going to have a terminal ray. And everything else that follows depends upon your independent choice of theta. Functions have independent and dependent variables. Okay? The independent variable for a trig function is theta. Now we're going to drop a perp. And notice if you, nope, don't draw theta. Oops. Okay. Oh, timeout. I just saw something. Okay. If you come around here, that's fine. That could be your independent choice. Okay. Is this theta? No. We drop a perp. In this case, you could drop a perp by going up. We don't drop a horizontal, right? That doesn't make sense. Hey, let's drop a horizontal. What does that mean? All right? You slide a horizontal. That's not your reference triangle. You drop a perp. If you want to do that first, this is theta. So don't make the mistake of mislabeling theta, okay? So anyway, I'm just drawing it in quadrant 1 because it's easier. All right, so now this is the point x comma y. So this would be x, this would be y, and we're not going to put absolute value around them anymore because that's only in planar geometry when we're talking about lengths. This is coordinate geometry, so x and y are actually vectors. Their absolute value is their length, but their sign is the direction. So we're going, in this case, we're going right and up. So it's positive, positive. And then this is r. And of course, we know that x squared plus y squared is equal to r squared by the Pythagorean theorem. Okay, so now that we have our right triangle, called the what triangle? Reference triangle. And again, in this case, theta is also equal to theta ref because we're in quadrant 1. Let's go ahead and start listing all the possible ratios. Okay, 2 at a time. Okay, let's list all of them. I'll start. I spy, we can do it like I spy a y over r. Yeah, good one. Thank you. I use my peepers for that one. Does anyone else see another one? Oh, what's the thing from 5, 6, 7, and 10? You got a lot of girlfriends. You know, some guy might just leave it down on purpose. Be like, come on, keep it coming. They're like, okay, dude, that's not how the game works. I'm walking away. All right. Good luck with the ladies. Okay. Anyone else see another ratio besides y over r? No? Oh, okay. Just any combinations of one over the other. Oh, x over r. Good. I'm going to write that one down here. Okay, great. Any others? Y over x. Hey, that's a good one. I'm just going to write that one down here below this one. I'm just working straight down. Y over x.
So Sohcahtoa is just 3 of these, like the total amount of combinations you can have.
Yes.
Oh.
I'm trying to, this is the point of the lesson. I want you to realize that. And you just did. So, no, perfect. Yeah. No, I just drew a triangle. I just labeled the 3 sides X, Y, and R. Right now, all I'm interested in is how many combinations are there of 2 things out of 3. All of the combinations. Some of you are jumping ahead, and it's like it's ruining a surprise. That's okay. Are these the only 3? Bye, Lisa. I'm recording it, of course. You see an R over X ratio. I do too. I'm going to write that one over here. Is that all of them? Well, what else is there then? You see X over Y. Fantastic. I'm going to write that one over here. You see R over Y as well? Great. I'm going to write that one right here. Any others that we missed? X over X? No, it has to be 2 of the 3. Well, we can mathematically prove that if you have 3 things and you're taking them 2 at a time, there's only 6 ways to arrange it. Okay? Y'all know that? Okay, good. Here's how you know that. These are independent events. You multiply independent events together. How many ways are there to pick the first side? No? The first side. Just how many ways are there to pick one of the 3 letters? There's 3 ways to pick the first letter. Right? Let's choose the numerator. Okay, let's make a ratio. How many ways can I choose the numerator? 3. Now that I've chosen that side, how many ways are there to pick the denominator? 2, right? And that leaves 1 left over. It's like, hey, I'm left over. What's 3 times 2 times 1? 6. So there's only 6 ways to arrange 3 things, taking 2 at a time. Yeah. Anyway, 3 times 2. So we got them all. We listed all 6. Now, as I was saying, these things were used quite a bit. So you don't want to just like saying, hey, what's up, X over R? Like, that's not my name. Yes, it is. I don't like to be called that, though. But that's on your birth certificate. I know. Can you just call me something else? Okay, Chuck. Nope, not Chuck. Guess what it is? This one is called sine, okay? This one's called sine, S-I-N-E. But as a trig function, I'm going to move these over a little bit. As a trig function, we don't write S-I-N-E. We abbreviate it sine, sin of theta. Sine of theta. And notice it's still O over H, isn't it? If you look at your reference angle, the opposite is Y, the adjacent is X, and R is the hypotenuse. So that's still so in Sohcahtoa. But instead of O over A, or I'm sorry, over H, it's what? Y over R. All right. So then they came up with a name for the next one, like sine. How about Chuck now? Nope. How about cosine? Okay. That's a weird thing. You got sine and cosine. Very imaginative. So that's cosine, and we abbreviate that COS of theta. So now they're like, okay, I see what you're doing there. Can I name the third one? Okay. What's the third one? Sine, cosine. How about cocosine? Right? We just keep adding co's. We can name it Coco for short. No. No, this one came to me in a dream last night. We're going to call this one tangent. All right? And I'm going to abbreviate it tan, you know. There you go. That one's called tangent. Those are the 3 main ones, okay? And that's Sohcahtoa. It is still opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. But you need to start memorizing them now in terms of X, Y, and R. Now notice the 3 that I listed in the other column, those are all the whats of the left column. Reciprocals. These are the reciprocals. Now you think they would just flip the names, right? That must be 1 over sine. It is 1 over sine, but we call it cosecant. What? I know, and we abbreviate it CSC of theta. The reciprocal of cosine we call secant. And we abbreviate it SEC, like Southeast Conference. And then the last one, the reciprocal of tangent, we call that cotangent. Yeah, I know, and we abbreviate it cot. Now, it seems weird. Tangent and cotangent are reciprocals. So why aren't the others reciprocals of each other? Why is cosine not the reciprocal of sine? Why is secant not the reciprocal of cosecant? Because the guys naming them weren't thinking ahead. Actually, co is going to stand for something else. Okay? So right now we're going to stop right here. This is how you want to memorize them. Memorize all 6 trig functions in terms of X, Y, and R. Okay? Tomorrow we're going to roll with that. We're going to introduce the unit circle, and then we're going to start quizzing every day. Yeah, so like if I say what is the secant ratio, you're going to be like R over X. Okay. If I say what's the cotangent ratio, you're going to say X over Y. What's the sine ratio? That's Y over R. Okay? So if you do nothing else today, try and memorize those in terms of X, Y, and R. Remember I said you want to stay ahead of the game. Memorize as you go. Speaking of going, y'all can go. There's no bell up here. Have a fantastic, great rest of your Monday. Thanks again for the song. Thank you so much.